mechanisms do we need to know to deploy our code into production? That is the effective question that I ask always. And there could be different teams in your company, probably multiple, more than one, or it could be one if you're in a startup. And the second question is, once we have them, let's say once we have defined them, could be multiple, which we'll see in the next few slides, how do we standardize them? And why standardization is important is because if everybody comes up in their own way, imagine you are running a company, and if everybody starts coming up with their own way of building machine learning models and deploying machine learning models, then what will effectively start happening is that there'll be too many technology stack and too many things to worry about. The firm might spend a lot of need specialized skill sets, and so the need for standardization is also very, very important. So you have Flask. You could always wrap your model into a Flask API. I'll probably show an example for this and also Dockerize it. You have TensorFlow for Kubernetes, wherein you have TensorFlow deployed on Kubernetes, and one of the very nice ways of doing that is using Kubeflow, which is very popular, which is growing, the popularity of it is growing very, very rapidly. You have Selden, which is another framework. You have Microsoft, AWS, Google, all of them have cognitive services of their own, where you can just go and use and follow a SaaS model, and you'll typically be very happy about it. Just get a machine learning model, or you could just probably do something on your own in Python. And this is not an exhaustive list, guys. There's tons more as we change this. Veka, there's probably SageMaker is already covered. We have Pachyderm, we have something called as Nucleus, which is very popular nowadays. So tons of different model serving frameworks, and I'm just throwing in words here. Now, effectively, to simplify this, what do we do and how do we solve our original question of productionizing a machine learning model? So to simplify, we can either consume a provider API wherein the model is either pre-existing or we have created on our own, a kind of AutoML scenario, stuff like that. Or we could build and deploy our application, which consumes a serialized model accessible over an API. And the emphasis is on the serialized model because all the models are saved as a serialized file, which is the pickle file or the feather file or whatever is the file format that you work with. Right, these are the things, these are the model files that we typically work upon, right? And now we are going to jump upon one piece of, let's say the last slide, which can help enable the build and deploy pieces. We'll talk about the serialized part also shortly. Now, when we do build once Java, is there a question? Okay, somebody left. Right, so when we have let's say Java folks here, if there are any. Okay, there's a question. Let me take that because this seems very interesting. What more complexities come into a picture for online learning of model? When model trains continuously in production using real-time data, it receives like. This is a good question, sir, Satyarth. I think I'm gonna come up to these questions very, very shortly. Yes, you're right. The retraining kind of puts a little dent in the whole schema of things. Right, it's very, very, how do I say, not usual way of doing it, because retraining typically involves scenarios where you will need a much larger compute. Also, if you are retraining in real time or almost a near real time scenario, let's say where your model is getting updated every day or something, you need also some sort of a model versioning system. We are going to touch upon some of these briefly and probably lay out the key pointers on the key answers to this. All right. So build once, run anywhere. And why am I talking about this? Because Java once had a notion of let's say write once, run anywhere, and that quickly evaporated because if you have used a Java application, you know this is not true, because you could probably develop in Windows and it could go haywire on Linux or Mac. Also, it could go haywire on a different machine, or it could go haywire in a production scenario. It's very, very difficult there. Now, but that is a development language. What we are going to talk about is standardizing deployments and doing it through containers. Now, in a traditional schema of things, and I'm sure all of you have experimented, you could have a Windows laptop here, something like this, which is your infrastructure. Then is your hypervisor, which could be the Windows hypervisor if you're running a Windows, let's say Pro Edition, or it could be WSL2. No, WSL2 does not allow, it allows subsystem, it allows a different layer of virtualization kind of a thing. And then, or a virtual box, very simply, you could think of this blue box as a virtual box. And then you are typically creating virtual machines And what these virtual machines will have is, let's say the bottom horizontal is Windows, this could be Linux, this could be Ubuntu, sorry, this could be Linux Mint, this could be Ubuntu, this could be Kali. And all three machines would be different. And imagine this further, where your machine had, let's say, 12 GB of RAM, and your core OS is kind of consuming most of it, like let's say 3 GB of it, right? After it, you will have to physically allocate memories into each of them. You do not have a concept of shared. Even if system A and B, VM A and B are not using anything, this application which is running on virtual machine C will be constrained by the memory allocated to it, which means you could have a wastage of infrastructure here. Also, the guest OS kind of eats up some system resources, which is not very good in a let's say production environment. That's where containers come in. That's where containers are outshining these days. And I'm not comparing effectively between a container and a VM. I'm just specifying, because both have dedicated use cases. It's not either or question. It's probably what fits your use case. You're effectively abstracting your runtime engine. Your applications are packaged in a way that they can benefit from a, let's say, shared memory kind of a practice. So in this environment, in option 2, we have the host operating system, we have Docker, and we have app A. Let's say all of these apps are not consuming a lot of memory, then app A is kind of free to expand. So Dockers or containers by their nature are more elastic than virtual machines, which is a very key takeaway from this, let's say, talk or the short discussion. Containers are more elastic in the sense of the usability of the infrastructure, the CPU and the memory. Also, the amount of time it takes to spin up a container is much faster than a VM. You could typically spend a couple of minutes, or maybe less than a minute, or more than 5 minutes, depending on how bulky your virtual machine is. And that can be done through different mechanisms like ARM templates or things like that. But on containers, they're much faster. They stop pretty fast. So even if they crash, they come up very fast. That's one of the core benefits of it. There's much more, and we'll touch upon some of these, but again, this is not a container specific talk. In a traditional deployment in your machine, what's happening is, and you may be solving this problem like by using a Conda environment or a virtual environment, but imagine if you don't use either, this is what you will end up with. Traditional OS, where on the left hand side you have your machine things, kernel, systemd, Docker, etc., and then you have your whole application stack, Python, Java, Nginx, SQL, ABCD, and then you could have different applications. In this scenario, you cannot run Python application 1 on Python 3 and application 2 on Python 2, simply because you are running a traditional OS and you're not using any kind of wrapping or virtualization. Virtual environments and Conda environments kind of help you achieve it, but you do not really rely on virtual environments and Conda environment in production. That's not the way your servers are structured. That's more of a, let's say, development kind of a scenario. I'm sorry about that. So in a container landscape, what happens is you have a machine, which is your traditional OS. And again, this is a Linux example, but it could be anything. You have a machine where it's containerized, and then your container image typically has everything. It could have, let's say, all the packages it needs, and all of these green boxes are one container images. So each of them are independent and kind of have all the dependencies that they need to run tagged inside it. If I probably take a more deeper dive, should probably have this before. So the way they are operating, the way containers operate is, imagine see from the top and then look at the bottom of this stack, right? So you have a base image, which herein is Ubuntu, on top of which everything would run. So you would typically then download Oracle JDK. You would typically download, you will typically then again run that command. So the first run is run the curl command, and the second run is kind of run the tar command. And then you probably again are downloading certain things, and then you're copying it, you're exposing a port, and you're creating an entry point. I'll show this example for a Python application also very shortly in the demo, but this is where containers work. You typically write them top down, where the base image kind of each of the base is stacked up in this way, and then on the very top you have the, let's say, the read write layer through which you have your entry points exposed and whatnot. So this is how your application would work, right? It will be packaged, and then once you take it onto any machine, it could be any machine, it is just expected to work this way, right? And that's exactly what the workflow also specifies. If you see, what's happening is, this is a host 1, right? This is probably my machine. This could be my machine, right? Host 1. And then I created a Docker file for it, and I created a container, and then I posted to a container registry. What this is going to happen is, this could be my machine learning application with the REST API, Flask API around it, and all the configurations. What will happen is, anybody can pull, probably anybody in the stock can pull that up from their machine and just run it as is. They do not need to download anything. All they need is Docker, which means that I've successfully packaged my software in a way that it can be distributed without any, let's say, changes in its properties. There'll be no change of properties required from probably the core code or the core functionality. Yes, we need to still talk about scaling and stuff like that, which we'll touch upon, but that's pretty much it, right? This is the overall workflow. Now moving on, these are some of the simple commands in Docker, right? This is effectively a very simple view of what and how Docker to interact with Docker. You do Docker build, and I'll show you this through an example right now. Is you do a Docker build to build an image. You say Docker images, it will show you all the images. You say run, it will run an image which is an executable container. You say ps, which is similar to the, let's say, Linux px commands. It will show you all running and stopped instances. You do a stop and it will show you, it will just stop it. You do an rm, it will delete it, and which is remove the running instance, not the image of it. Remember, image is like an ISO file, and the instance is the runnable of it. So that's the beauty of it. And then Docker RMI, where you are removing an image. Now let's take a quick demo here. I'll walk through a very short app. The idea is not to kind of overwhelm it, but show it. So this is my app, right? What this is doing is, this has two pieces of technology. There's no while on my machine all of these exist, but I'll show you how it's independent of my machine. So I'm importing OS, I'm importing socket, I'm importing Flask, and I'm importing Redis, which is kind of used to manage a counter here, which for some reason doesn't seem to be working. And all I'm doing is just connecting to Redis. Probably this is where the issue is in my error. But this is a simple app route where on the browser you'll be able to see that hello will be printed, right? And then the counter. This is what is the interesting piece, right? This is where we have the Dockerfile, which I was specifying that we build from top down. So you say from Python, and what it will do is it will connect to Docker Hub and pull Python. Then you set the working directory and tell Docker, or which is, let's say, the container image, that my working directory is app. And then you copy everything into app. So all my app, my py requirements will be pushed inside it. And then what I need to run is, I'll show you my requirements file. I have just two things, Flask and Redis. But this could be anything. I could install, put anything here, right? The idea is just, I can write 300 different things and all of them will be installed. The important messages, they will be running and installed inside the container. So you typically do a from, set the work directory, copy all your code, and then you do a run pip install where all of your, let's say, libraries are installed. And then you expose a port, right, outside of which needs to be accessed outside of this container, because the container is in itself and has an operating system. It needs to know what ports will be used. I need to do outside and inside. That's the networking. And then you can have your environment variables set or not set. And then finally you specify run this when the container launches. So you do a cmd and you call python app.py, very similar to what I will do in this, if I were to, let's say, connect to it using a command line, right? So this is my app.py. This is what Dockerfile is. The Dockerfile is helping it run it, kind of execute all of the things and install things. The requirement is to manage all my different libraries that I need to install. I'll show you what I did is, just before this, I started this and you'll be able to see all of the stuff that happens. So this is where I have built my container. As I showed, it's a pretty simple way. So I told Docker build, and you need to be inside the working directory to be able to run this command. And tag friendly hello, which is just a name for my container image, and you put a dot. Again, this is very similar to Git, right? You have to put a git add dot, and it will pick all of the things in that folder, right? The first step was from Python. right? What it did is it downloaded the latest image of Python here, right? There's a Python image which has been downloaded to my machine. It changed the working directory, and then there was an intermediate container, it removed it. And this keeps on happening multiple times, the removal of intermediate container, etc, etc. Then the step 3 and 4 were kind of, step 3 was to copy it, and step 4 was to run the pip command. And this is exactly a pip command as you would run on your machine or using a conda environment. So what you have is, you have collected Flask, you have collected Redis, you have collected all the dependencies around it, right? And this could be anything, this could be any application, right? Then you are exposing the image, and then you're removing the interface. You're kind of, let's say, again, removing the intermediate container, and you're exposing the port 80. The environment variable is kind of, I don't think I've used it anywhere, but it's just to show that you can do it. And finally, you will get a successfully tagged message and a warning where, because I'm using a Windows host, and the base Python image is using, I believe, Linux, and that's why this error is there. But this hasn't caused me any issues. Now I just did a Docker image ls, where you see that this was created some time back, and it's not really 9 seconds, it's probably 1 hour right now. And then yeah, there are a couple of errors here, and I corrected the port mapping, and you need to specify what port you need to run. So the outside port goes on the right, which is when I specified in my app.py port 80, and the port on which my machine this is running, it's 4001. And as you can see on localhost 4001, I'm just calling this. Now this counter seems to be not working, but this is getting refreshed because this is connected to live server. You see, you're getting a message every time I do this. It's kind of a live. So that's how you typically have a machine learning example. Very similarly, you have a API which is wrapped around it, you package it, and then you kind of deploy it, right? That's effectively the message, and that's pretty much the core idea of this talk.